Okay guys, let's to continue. Now the turn is for factor a perfect square trinomial. It's a case of the first term is a square and the last term is a square also, and the central term is 2 times the first term by the second term. That's the solution. We are going to work immediately a group of the exercise that represent the perfect square trinomial. Go ahead.
Okay guys, let's to try the perfect square. Imagine that we have in a square that side a plus b and a plus b. The area, when we multiply a plus b times a plus b, is the area, which is a plus b to the square. It's perfect square because we multiply by itself one side by the other side. The same thing, instead that a plus b is a minus b or a minus b, the square will be a minus b to the square. When we multiply a plus b by itself, which is the same thing that a plus b like this, as if we have a negative sign, negative sign, negative sign, the answer of this product, we obtain this trinomial, which is a to the square plus 2 times the first term a for the second term b plus the second term b to the square, considering that a is the first one, b the second one. If the sign is negative, then in that case this central term will be negative. Okay, then in that condition, the following exercise, 9x to the square minus 12x plus 4, we can consider that that trinomial is a perfect square. If we check our first term and the last term, both will be a and b are the origin is for the square, the expression for the square. We can rewrite that expression in 3x to the square, which is my first term, minus 12x plus 2 to the square, which is b to the square. If the central term is the product of the 2 times ab, then we are in presence of the perfect square. In that case, we said that a is 3x and b is 2. The central term, which is 2 times ab, don't forget the sign, which is right here, negative sign. The product will be 2 times, let me return to the black. The product will be 2 times 3x by 2, which is the same thing that 12x. In fact, we have in presence of the perfect square. That is a perfect square because we can express that expression as a which is 3x minus b, which is 2 to the square. If you develop the product of these two parentheses, you get again the origin 9x to the square minus 12x plus 4. Perfect square. The answer is a perfect square. The factorization of this trinomial is a perfect square. Check that the coefficient of the x to the square is different than 1. But instead that you solve it by AC method, check first if that trinomial is a perfect square and solve it with this method. The next exercise is another trinomial that has a coefficient of the x to the square different than 1. We can perhaps confuse with the AC method, but if you check the first term and the last term, and both you can transform in expression of a quadratic term like 5x to the square and 2y to the square, if that is true, the only thing that you need to check if the central term will be, as a formula, 2 times ab. Consider that a is equal 5x and b is equal to y. Let's to solve that central term. And do 2 times 5x multiplied by 2y. Answer 20xy. In conclusion, the trinomial that we have right here is exactly a perfect square because the first term is in form of the square, the same thing the last one, and the central term is 2 times the first one by the second one. Then we can say that the answer of this trinomial that we have in the top is exactly the perfect square. Let me change to the black color. It's a to the black color. Okay. Is a perfect square. 5x in this case is positive, 2y to the square. Again, if you develop 2 times this parenthesis, you get the original trinomial, perfect square.